I just looked at your answers for that you've submitted. I think maybe, I don't know, 15 or 20 people have submitted answers so far. Only 2 people have gotten this right. Most of you have chosen D. Most of you have chosen D, and D is 0. So I can almost guarantee that you're going to just kick yourself for not getting this right, because it looks to be a very simple problem, and sometimes even the most simple problems, if it looks too easy, then there's a catch to it, and I almost can guarantee that the absolute max of this function, now I guarantee, I promise I have not looked at this problem yet. I mean, looked at it, but I haven't done it yet, so maybe I'll make the same mistake you do, but D is the wrong answer. Okay, that is not right. And I'm looking at the answer, so I already know D isn't right. 1988-33 is A. So A is the correct answer. Okay, and that's a 4, and let's just see how we get there. Alright, so I do have the advantage of knowing what the right answer is, but this is my first time through the problem. I'm going to work it through and give you that video. But again, I almost guarantee you that the maximum will occur at one of the endpoints. Okay, so let's take a look. We already know that f prime of x is what we have to find. So f prime of x, and this is how I would do it. I wouldn't even write the x. F prime equals 3x squared minus 6x. Okay, so super simple to set this equal to 0, right? Because you already know how to factor that. So 3x squared minus 6x equals 0. So this is a good review from section 4.4, the optimization, absolute max, and even back in 4.3 where you're trying to find an absolute max. Okay, so f prime is equal to 0 or f prime does not exist is when we will find our critical points. Okay, just want to review that part right there. These are where we find critical points. This is where we will find any maxes or mins on the interior, okay, on the interior of the interval. But again, these are the endpoints. Okay, these are endpoints. And endpoints are also where we may find extreme values. Okay, so you just got to be careful when you see a domain like that. Anyway, f prime equals 0 is the only place that we're going to find critical points, because f prime exists everywhere else on the interval. It exists everywhere for all real numbers anyway. But we're going to factor out a 3x, and we're going to get x minus 2 equals 0. So when x is equal to 0, and when x is equal to 2, we've got 2 critical points. And those are in fact at on the interior of this interval. So let's go ahead and make our sign chart. Where is it? And the left-hand side of the interval would be the -2, and then the next number we come to is a 0, and then we come to a 2, and then at the other end we've got a 4. So the f prime, let's check f prime out on the interior of this first interval. So -1 will be our test value. -1 causes the first factor to be negative, and then -1 causes the next factor to be negative. So we have plus, plus, plus. F prime, this is our f prime test. F prime is positive on that interval. Let me just double check and make sure I got that right. Yeah, negative times a negative, that's positive. Alright, so in between 0 and 2, we can check 1 out. So the first term here, 3x, I'll just call it, 3x is positive. And then, though, 1 minus 2 makes that second factor negative, and so we see that the function has negative values on that interval. And then, see, d equals 0. There you got suckered in. That's the sucker answer right there, guys. That is the sucker answer. And hopefully you only make mistakes on this one time. 2 to 4 on that interval, we can see when we replace x with 3, we've got positive f prime, positive times a positive. And so what would the shape of the f of x look like on the interval from -2 to 4? Well, f prime is positive, meaning that f is increasing. F prime negative means that f is decreasing. And f prime positive means that f is increasing again. Well, we have a max value here. That again is the sucker answer because of what I said. Okay, and then we have another max here at an endpoint. And as I said in class, the critical points and the endpoints, the basics, okay, going back to the basics, anytime you're trying to find a max or a min, these are the only places where you're going to find them, and you have to check. Okay, all you have to do is compare the local max at 0 and the local max at 4. So comparison, let's do that. Okay, so let's compare. This is like comparing Mount Whitney to Mount Everest. Okay, well, which one's higher? That one gets the title of absolute max. Well, Mount Whitney is a lot shorter than Mount Everest, so Mount Everest is the absolute max. So we're going to compare f of 0 and f of 4. Okay, well, by now you probably can see what's going on. F of 0 is, we look back at f of x. F of 0 is 12. Okay, f of 4 is 64 minus, oh my gosh, so we've got 4 cubed. 64 minus 3 times 4 squared. Let's just make sure we understand how we're getting there. And then we have that plus 12. Okay, so 4 cubed is 64. 3 times 16 is 48. Plus 12. Well, we already know that 64 minus 48, that's going to be, and then add 12, it's going to be positive. So we already know it's going to be bigger. But 64 minus 48 is 16. 16 plus 12 is 28. 28 is greater than 12. Mount Everest is greater than Mount Whitney. And so it says, what are we asking? The absolute maximum value. Oh, so the absolute maximum value is the really? The absolute maximum value is occurs at. Gosh, I was freaking out there because the value is actually 28. But I didn't read that last part. Occurs at x equals, okay, so we got it. So occurs at x equals 4, and so 4 is the right answer. We already said that. That's A. Sorry, that's how it goes. You know, if they had a 28 there, I may have chosen 28. They should have put a 28 there. It might have gotten me. But they didn't have a 28 there, so I read it wrong. But now you know it occurs at x equals 4. So I hope that helps you. I hope it didn't make you feel bad. But you know, you're going to be angry at yourself because you didn't check that endpoint. But you can't just overlook that. Most of the problems we do, yes, you don't have any endpoints, but some problems you do. Okay? So let that be the last time you get snookered into choosing the wrong answer on one of those problems. All right. We'll see you in class.